In this video, we're going to talk about the basics of a Windows virtual machine in Azure. This is a Windows virtual machine. However, most of what we're talking about here will also apply to Linux. So what I have here is I have one of the lab exercises, just using this as a sandbox so that we can continue into the Azure environment essentially for free. And so I'm going to go ahead and I'm going to activate the sandbox here. And then when it's done, I will go ahead and create a virtual machine. So the creation of a Windows virtual machine is pretty simple. It's not overly complicated, especially now that we've already been in Azure for a couple of times. We probably would be able to figure out most all of the things that we're looking for. With that being said, there are some uniquenesses that make the Azure virtual machines special. Let's see, finishing. All right, sandbox activated. Go ahead and create a new virtual machine. So as you're probably expecting, we would come over here, click create resource. I could also just click virtual machines right here, but I'm going to click create new resource, and I have lots of default options under popular. I could also click compute, and that would give me all of the options for compute or computer type activities. I'm going to come back to getting started, and I'm just going to click 2016 data center. That's ultimately what I'm looking for in this environment. As you've already seen before, we start off with the subscription, which is concierge, and the resource group, which is not populating. There we go. And the resource group. We can go ahead and give it a virtual machine name. You'll notice there's no mention over here on the right hand side that it has to be wholly unique. So we can actually name this test or my VM or whatever generic name we might possibly want. You probably want to have some sort of a naming scheme. I'm gonna start off with like AZR to be able to specify that this is an Azure, and then just test VM1. Really, the only requirements are right there. It has to be pretty much a Windows OS computer name. The region, because I've had issues in these labs changing the regions, I'm going to leave the region as is. And then availability options. Now you may have remembered that there are both regions and availability zones in Azure. If I look at the Azure regions, then basically I have two options here with my choices. One is I can have two virtual machines in two different regions. For instance, I could put one virtual machine right here in West US and then another in East or South Central. There we go. That way I have two virtual machines in two different regions. If one virtual machine goes down, then the other one is up and running. My other option is to use what's called an availability zone. An availability zone basically has two or more buildings built right next to each other, and they are connected with a high-speed communication, and therefore I can have one VM right there and then another VM right there. They're both in the same region, but they're in two different buildings. So if one entire building goes dark, the other building is still up and running. So those are my options. I can either have no redundancy, or I could put it in an availability zone or an availability set, which will essentially double my virtual machine count here. Instead of building one, it will build two. Instead of charging me for one, it will charge me for two. The image, I went ahead and chose 2016 data center on the creation wizard. If I wanted to, I could change that at the images than just this. These are the ones that are available through this wizard. Otherwise, I go back and choose the correct image that I want. Size. This is the size I want. If I wanted to, I could click change size, and we can actually see there's lots and lots of different sizes. We can go from virtual machines that cost like $3 a month. Ooh, Actually, can I sort? According to this, let's see, from $8 all the way up to nearly $3,000 a month. That seems low. Yeah. There are some filters here. See, size, small, current gen. Yeah. We will close that because I want to stay with the default. Administrator account. By default, you're going to think, oh, I want to go ahead and type administrator. However, you don't want to do that because everybody knows about the administrator account. So much so that if I type in administrator here, it calls that a reserved word. I can't use administrator. It's just bad form. You want to name it something else. I'm going to continue with the bad form and call it test admin. You would probably want to have some other name that you use for administrator, like Joe or Sally or Wonko or whoever you like. Password. Password 01 does not work. It has to be between 12 and 123 characters. I'm going to do password 0123, which is just enough. Oops. Do not do this in a real life environment. I'm simply using that simple password here because it's a sandbox and I know it will be deleted as soon as the sandbox is gone. And I cannot be negatively impacted by this. Scrolling down, it asks us for the inbound port rules. By default, there's a firewall here and it will enable none. I can, however, allow selected ports. For instance, if I wanted to run a web server on here, I could choose HTTP and HTTPS. If this was a Linux machine, I could choose SSH. However, it's a Windows machine, so I will choose RDP as well. You may or may not want these, depending on your situation. Last option as I scroll down, save money. Do I already have a Microsoft Windows license? Have I already paid for this Windows license that was previously in my data center and now will be in the cloud? If so, I say yes, it saves me money. If not, I say no, and I essentially pay for the Windows license on an as-needed basis. If I run this VM for 1 minute, I pay for a license for 1 minute. If you're not entirely sure, chances are you want to hit no. All right, next to the disks. It gives me an OS disk by default, and I can choose standard HDD, standard SSD, or premium SSD. You could choose a standard HDD. Maybe you don't need a whole lot of performance from this machine. You just need it to be on. However, the default is premium, so I'm going to go with that for this lab. If this was going into production, I would actually look to see what my requirements were. Data disks. I can configure additional data disks. I won't do that at this point. Networking. It will create a network interface with this weird, interesting name right here. I could change that if I want. It will put it onto a private subnet of 10.000/24. I could change that if I want. And then we'll give it a public IP, which will be chosen when the machine is powered on. Next, security group, and then the inbound ports we already defined, so we can continue to configure those. Network acceleration, not supported in this configuration. And then load balancing. If I know I'm going to have more than one machine behind this, I can choose to have a load balancer automatically built in. So I could have a load balancer connecting between the internet and then one or more virtual machines on the background. Because I'm just simply doing a single machine here, I'm going to say no for the load balancer. For management, there's lots of management options in here. I can turn on Security Center. There is already a basic plan that's provided by default. I can go to a more advanced plan later. Boot diagnostics. This is great. It allows me to have a serial console and create snapshots of the machine as it's booting up. For instance, if the machine starts booting up and it hangs, maybe it's stuck with a check disk error or something along those lines, this will actually take a screenshot of that, which I can then look at to find out why my machine's not locking in. Guest OS diagnostics. This allows me to centralize my log files and alerts and be able to see everything at one time. Identity management, so I can use, once we get into Azure AD, I can start using identity management, as well as auto shutdown, maybe at 7 p.m. Pacific time. Other way, -8. Actually, let's say 6 p.m. 5 p.m. UTC. 5 p.m. Pacific time every single day. This machine will power off. And because it's powered off, it costs me less money. I'm going to leave that to off. Advanced. I can get into some cool extensions and automation tools. We'll worry about that later. And then tags. Tags are useful for organizing your environment. For instance, I can create a tag here called department and then a value of HR. I can create another tag for, let's call it state. There we go. And then maybe the state is testing. Maybe it's a testing environment as opposed to production. You can create lots of different tags in here, and these are all used for organizing your environment, for searching through them, as well as for billing them. So you can start consolidating billing and say, hey, HR is taking up a whole bunch of resources in my environment. Let's charge HR for them. Lastly, review and create. Gives us a nice little review of the environment. I'm going to click download here. Actually, I'll click create. So it's going ahead and it's creating this virtual machine in the background. Let's download a template for automation, which we can also do right here and download. What this is this is a template of the configuration I just chose. It allows me to essentially codify everything I just did. What that means is it comes out with a bunch of files that look like this. Very quickly, we have a deploy PowerShell file. We have a deploy shell script to run under Linux, and then we have a deploy Ruby file here if we have some sort of a Ruby scripting environment. If I open these up, if my computer will let me open them up. So I have the PowerShell ISE. We can see through here, it loads up a lot of parameters. It, let's see, tries to register me into Azure. Signs in, selects my subscription, finds my resource pool, or resource provider, excuse me. Creates the resource group if it doesn't already exist. And then starts a deployment of the virtual machine I just created. What exactly does that mean? Well, let's look at the parameters file here. Here we can see all of the choices I just chose, such as our location, our network name, which ports we've allowed through our firewall. Every single choice we just made has been codified or listed in a configuration file here. Because I just created this one virtual machine called EDS. This is from a prior one. Let's say I created a virtual machine called EDS VM, and now I want to create a new virtual machine. Let's see, that was AZR test VM02. Basically, I just changed the configuration file, I save it, and then I run this deploy script right here. The deploy script will go ahead and find all that configuration from the parameters.json file here and rerun the configuration for me. Where this really comes in handy is not just when I'm deploying one machine, but when I'm deploying a lot of machines. For instance, if I have this configuration right here, I have, let's see, 1, 2, 3, 4, 5, 6, 7 VMs. So 7 VMs plus 2 databases. 1, 2, 3, 4 load balancers, 2 NVAs, and 1, 2, 3, 4, 5, 6 networks. I can codify all of these items here. I can codify all of these components into one script or one set of scripts. And what that means is, say I am a service provider, and part of my service is to provide this environment. I have all of the software for this environment all configured. I came up with this environment, and I've decided this is my product. All of the software and all the configurations in this environment. I can then codify this environment into a script. Customer number 1 comes along, I run that script, and I build out this environment specifically for that user, or for that customer. Running the script takes me about 10 minutes, and their environment is up and running. Customer number 2 comes along, I run the script again. Again, it takes me about 10 minutes. Customer 3, customer 4, 5, 6, all of these customers takes about 10 minutes to run. Customers are happy? It takes 10 minutes. That's almost immediate. I'm happy because instead of having to build out each of these virtual machines and networks and load balancers and NVA appliances every single time for every single customer, I only did it once, and then I run the script and it builds them out automatically. Everybody's happy, customer gets what they need faster, and I'm able to start billing quicker. So, codifying. Basically, it's doing an environment as code. Computers as code, believe it or not. So that's what the templates and the JSON files are. There's a whole lot to learn there, a whole lot of practice that need to be done in order to get it to work properly, but that is the ultimate goal. All right, hopefully our deployment is done. Yay! All right, so I came over here, I clicked on all resources. Just, you see the little tab there, it says all resources. When I created that virtual machine, it created more than just the virtual machine. You can see it created, yes, the virtual machine right here, but it also created a public IP address, a network security group, network interface, disk, storage account, and I believe there's actually more. Virtual network, another storage account, and then all these NSGs are part of the lab. Ignore this. So it created all of these resources, and it actually makes our life so much easier because, for instance, let's say I like my hard disk. I like all the configuration that's on it, but my virtual machine just isn't working for some reason. What I could do is I could take this hard disk, I can detach it from this virtual machine up here, and then build out a new virtual machine and attach the hard disk to it. I can just detach and reattach things. I can move them around to new environments. Same thing with the network card. Maybe I like the IP configuration I have, or the network card that I have. I can detach that from the virtual machine, reattach it to a new one. Excuse me. So now that our virtual machine's up, let's go ahead and check into that. Virtually, let's start off by looking at the overview page here. We can see, well, resource group, not too exciting. Ideally, we would have named these resource groups like HR, accounting, IT, lab 1, something like that, so that we could then identify which group these belong to. Status, is this machine running or not? Running means I'm paying for it. Not running means I'm not. Location, subscription, computer name, size, public IP address, as well as the private IP address. I get both. And then I can also configure a DNS name. Let's start off with Connect up here at the top. Connect allows me to connect to the remote desktop. Well, yeah, let's try that. I click Connect. It says, great. You have two choices, RDP or SSH. I only chose RDP for a connection type, so we'll use that. If this was a Linux machine, I would choose SSH. Asks me which public IP address do I want to connect to. I only have the one, and then the port number, and it downloads an RDP file. If you've never seen an RDP file, let's check that out. I've got this RDP file right here. What you could do is you can actually open up Notepad. I'm just going to click and drag this RDP file into Notepad, and you can see the full configuration right there. I know this is going to be really boring at this point. Hey, here's the IP address I just said to connect to, port 3389. That's the standard RDP port. And then a couple of switches telling it to go ahead and prompt for credentials and use an admin session. I'm going to go ahead and double click on this, and it will bring up a remote desktop connection tool here. Say connect. Asks me for credentials. You'll notice by default it tries to log me in with my standard credentials. I logged into the desktop. I actually have to choose more choices right here. Some more choices. Use a different account. And then username here, I type in my test admin that I created previously and my password 0123. If I want to connect to this multiple times, I could click remember me. I'm only going to connect to it this one time for this lab, so I'm not going to check that. I click OK. It then prompts me one last time, and it says, hey, this is the first time you've logged into this machine. You don't know who it is. Do you actually want to connect? Yes. At this point, it should be connecting. There we go. And it's a desktop. Shortly. There we go. I have to scroll here because it tried to open it on another window. So it gives us the standard, hey, this is a new network. Do you want to trust it? I'm going to say no. This is actually connected to the public internet, so I don't really want to trust that. It then fires up Server Manager and everything that you would normally expect in your environment. While we're here under Server Manager, let's click on Local Server. And one of the things I want to mention is once we get into the network view, come on, Server Manager. It's a little slow because it's the very first time anybody has ever logged into this virtual machine. There we go. So once we get into Server Manager and we look at the Ethernet right here, we will see specifically it says IPv4 address and IPv6 are both assigned by DHCP. This is not a statically assigned address. Well, what exactly does that mean? We looked at the web page here. There we go. And it says we have two IP addresses. We have a public IP address and a private IP address. How are these not statically assigned? Well, it has to do with how Azure assigns these IP addresses. There's actually a DHCP server in Azure that goes ahead and assigns this address to this virtual machine. If we don't want 10.0.0.4, maybe we want 10.0.0.6, we don't change that in the virtual machine, we change that in Azure. So can I get to it from here? No. If I come over here to networking, I have to jump through a couple of hoops here. There we go. IP address. That's not what I want. Let's go all the way back. Let's go to the NIC right here. IP configuration, that's what I wanted. And then IPv4 address, I click on that. And down here it says go ahead and choose 10.0.0.4. I can change that to 10.0.0.6. Click save. I don't want to click save because it actually will reboot my virtual machine and then I'll have to log back in. But I could click save and then it will be assigned to 10.0.0.6. Discard that. All right, so that was step number one. Let's go back to our virtual machine. There we go. Just to confirm that, we can go ahead and we can look at the network properties down here. And then we can look at the adapter properties. in IPv4, and we'll see, yes, it is in fact DHCP, exactly like you would expect it to be. But yeah, so the DHCP server in Azure knows that this virtual machine should now have 10.0.0.4, or if I changed it to 10.0.0.6, and then every single time this machine's rebooted, it will get the same IP address. It's just a matter of where you change those IP addresses. If I change it here, it will break a lot of things. So don't do that. Second thing I want to mention about the Azure virtual machines that is unique to our environment is the hard disks. Now, when we built out this virtual machine, let's come back here. Let's see, where's disks? Oh, that's right there. There's the OS disk. We can see that we chose a 127 gig premium SSD. If we look at our virtual machine here, we have not just our 127 gig SSD. It is actually 127. Remember, there's the boot partition that takes up a little bit of space. But we also have this second 7 gig disk that says it's temporary storage. Well, temporary storage, I'm not paying for that. Why do I have it? Well, let's look into it. And it says that there's a text file right here. If we look into it and make this font a little bit bigger, just because my eyes are not as good as they used to be. There we go. It says, warning, this is a temporary disk. Any data stored on this drive is subject to loss, and there is no way to recover it. So if you put data on here, it will get lost and you cannot recover it. So do not use this for storing any personal or application data. And so the question comes, why do we even have it then? What would I use this for? Well, there are some things that you want a fast disk that you don't necessarily need to be persistent storage. First off, let me talk a little bit of background about what this means. Erase this here so I can draw on the screen. So, if in the Azure data center, there are a whole bunch of servers, and in these servers, there are a couple of HDDs, probably SSDs, but we'll call them hard disks, physically in the server. So this is the Azure server. And when you start doing the math, how much disk space does a Windows machine actually need in order to boot? Let's say that I need 8 gigabytes of storage to boot for Windows. Well, how much can I actually buy? Like, how small can I actually buy an SSD nowadays? It's probably somewhere around like the 127 gigabytes total. It's probably more than that if you're buying in bulk. So if I have 127 gigs, and let's assume that these are mirrored. If I have 127 gigs, but I only need 8, then that means I have 100 left that is free to use. Well, since I'm hosting virtual machines for clients, why don't I let some of my clients use that storage? And I'll just carve out a couple of gigs for you, a couple of gigs for you, and everybody gets a couple of gigs. So everybody gets some really, really fast local storage. So this storage is fast. I don't have to connect across a SAN in order to get access to it. It's local, so that means I don't have any latency. So it's really fast. It's local. It only exists while my machine is on, while my VM is on this host. It only exists, so it could disappear at any time. So what could I use on my VM that requires fast storage but doesn't require it to be persistent? And that's where we start thinking about some of the things that we could do here, such as swap space, virtual RAM, virtual memory. It utilizes a local hard disk. The faster the better. So if it's on an SSD and doesn't have any latency in order to access the SAN, then even better. So I could start putting my swap space on this temporary disk. What happens if I power off my machine and all that swap space is lost? Nothing. When I power my machine back on, it will recreate that swap space on that temporary disk. Additionally, if I'm using something such as a SQL database, you can have a temporary temp DB. There we go. A temp DB on that drive. The temp DB is essentially a whiteboard. It's a scratch space that somebody uses in order to temporarily work with data. So I store my temp DB on this temporary disk. Machine gets powered off, temp DB goes away. As soon as I power it back on, a new temp DB is created. So I'm not necessarily losing anything as long as I correctly put it in my environment, or correctly configure what data I put on my environment. So this swap space can be fairly useful because it is very fast. It's very local. There's no latency whatsoever. However, if I start putting, say, resume.doc right here, then I'm going to start losing my data, and that's not a good thing to lose. All right, so that's the virtual machine. Those are the two main things to watch out for in a virtual machine. Is the data disk, the temporary disk, it gives it to you for free. And then the second is the network. Don't change the network in the VM, change the network in Azure. All right, while we're here, let's see, I've still got a couple more minutes in this lab. Let's create some more resources. Let's see. What I want to do is I want to create a new hard drive. So we already have an OS disk. The rule of thumb is the OS disk should only have the operating system on it. And I'll show why here in just a second. Let's see if we can create a new disk if the lab will let me. Add data disk. Create new disk. Let's call this, I don't know, let's assume that this is a SQL database. So SQL data 1. Actually, 01. I always like having double digits in there. Resource group location is the same as my virtual machine. Size 1 terabyte, not a problem. We'll try create, see if it allows me to create it. While it's creating, first thing, this 1 terabyte SSD size is the maximum. You can't have more than 1 terabyte. It actually turns out to be pretty helpful. If I need more than 1 terabyte, what I do is I create 2 disks. And then in Windows, I just combine the 2 disks together. What that does is every single disk has a number of IOPS, or IOs per second. By having only 1 disk that's really, really big, then that means I only get 1 disk's worth of IOPS. But if I get 2 disks, each of which is 1 terabyte in size, then I get 2 disks worth of IOPS. So it is actually fairly beneficial to have to limit our size to some degree. All right, hey, it successfully deployed it, and so successfully created it. At this point, we're now saying go ahead and connect it. Has a choice for host caching, and then I'm gonna go ahead and click save. So it created the hard disk. Once I click save here, it will actually connect it to the virtual machine. It's just that simple to create new disks on our virtual machines. At this point, I should be able to go back into my VM. And now if I will see that I now have a new disk, hopefully. Right there. Disk number 2, it is unknown because we haven't formatted it. So let's go ahead and just make a new volume. Let's format it, bring it online. Brought online, initialized, yep, not a problem. F drive, whatever. I probably should have named it at that point. but we'll name it after it formats it. I must not have clicked the quick format. Oh, there we go. All right, so let's go ahead and rename this guy to data, SQL data. There we go. So why do we want to do this? Well, one, an additional disk gives us additional capacity, right? So here we have just gigabytes in size, gigabyte capacity. Additionally, an additional disk gives us more IOPS, more performance. So if we need more performance in our environment, we can just add additional disks. Thirdly, is it separates our data. And what I mean by that, what if I stored my database on the C drive? Well, okay, there's 126 gigs, 117 gigs free right there. So I can go ahead and I can store my data on that 117 gigs. Not a problem. But what happens if I try to do Windows updates on this machine, which I still have to do? If I do Windows updates on this machine and I brick it, like I completely mess it up, it's blue screening, I can hardly even get the thing to power on, then I'm in a situation where my data and my OS disk are on the same drive. However, if instead I put my data there and my OS there, and my OS drive gets corrupted somehow, blue screen, the entire disk gets corrupted somehow, what I can do is I can go ahead and I can kill that OS disk. In fact, I can kill the entire virtual machine and then reattach this to a new VM. At this point, I haven't lost any data. I may have to reinstall SQL for it to point to the new drive, but because my data was on a separate drive than my OS disk, I don't have to worry about losing that data. I only have to worry about rebuilding the operating system. It's a great way to be able to go. By separating out the roles in our environment, we're able to safeguard our data. Awesome. Let me tell you, the last thing you want to do is be stuck trying to rebuild an OS disk for weeks because that data is unreplaceable. Yeah. So by being able to have this data on another drive, that also simplifies your backups. If my OS disk only has my OS on it and all my data is on my F drive, that means I only have to back up my F drive. I don't have to back up my OS. Because one OS is exactly the same as another OS, I simply want the data instead. All right. So let's see what else we might have here. So we got the overview. We talked about that. The activity log. The activity log shows what administrators have done to your environment. So for instance, right here, it says I created or updated the virtual machine. If I was zoomed out, it would actually show that I created a new hard disk and then I attached it to the virtual machine. It shows who did it and it shows when it happened. Awesome. Why is this machine powered off? Who powered it off? Go to the activities and activity log and you can see. Access control. Once we start talking about Active Directory, you can start seeing how you can put role-based access control and administer who can do what in your environment. Tags, we've already talked about the tags. And then diagnose. Somewhere in here, there's a whole bunch of options. Somewhere in here is the actual boot screenshots we talked about. Networking, there's all the firewall ports that we can identify. We can detach our network interface, so we can actually just detach it from the internet. And then reattach that interface to another machine. Disks, if we need to update our disks or reconfigure them, we can do that. Swap the OS disk with another machine. Encrypt our disks. We can encrypt all of our data. Yay! So not even Microsoft can get access to it. Size. We're currently in one size. We can resize it as needed. We need more CPU because next week is like end of year and we have to do a ton of reports. Let's go ahead and resize it over the weekend. We'll bump up our size. Once the end of year reports are done, we'll size it back down. Security. The basic environment has some pretty basic security customizations or recommendations. Once we go up to the next stage, it will give us a ton of more security concerns in here. Extensions. We can add in customization extensions. Let's see, availability set. If we'd configured more than one virtual machine in here, we could configure what that should look like. We can also define at that point what our fault domain and update domains look like. Fault domains have to do with a common power source and physical network switch. Think a single rack of equipment. They all share the same common power source. Somebody trips over that power cable, everything gets unplugged. So you would probably want to configure multiple fault domains in your environment. If I had an availability set, really at this point, this would say like 5 or something like that, saying that there's 5 different fault domains, and it would spread my machines across all of them. The next option is the update domain. Remember, Microsoft is still maintaining this environment in the back end. It still has to do BIOS updates on the hardware. It still has to replace hard drives. It has to replace network switches, and therefore they call those update domains. So you want to make sure your virtual machines are spread across multiple update domains. Again, if I had multiple systems in here, I believe this would be like 3, so that all of my environments would be spread across 3 update domains. These are called scheduled outages, and these are called unscheduled outages. Microsoft does scheduled maintenance on your environment. It's just going to happen. The unscheduled, however, is the fault domains to then worry about. Change our hybrid configuration, or our configuration a little bit, so we could say, yes, we actually do have a license. We could start creating host groups in order to configure everything together. Identity, properties, locks, export the template here. Our auto shutdown, we can configure when we want it to shut down every single day. You can auto shut down, you can't auto power on. So you always have to be careful with that. Backup, by default, it will try to back it up. You do have to pay for the storage that it backs up to. See, I don't think I could choose the existing storage. No. You do have to pay for the storage for it to back up to. But by default, you can schedule these to happen, I believe, 3 times a day. And then it will be retained for 6 months. So 3 times a day for 6 months at any recovery point. Or sorry, backup point. Along with that, we then have disaster recovery. Go away. There we go. Disaster recovery. Oh no, our entire site has gone down. Let's see, we're currently in Central, North Central, and it says, hey, by default, I want to recover you to... Oh, we're in South Central. By default, I want to recover you to North Central. At that point, I can go ahead and I can configure replication. It will build out a virtual machine in North Central. It will replicate all of my data to North Central. When South Central crashes for some reason, it automatically comes back online in North Central. If I don't like North Central, I could choose a different one. East US instead of Central, or West US. It's my choice. Some are more preferred than others, and therefore I think you have to pay a little bit more for the non-preferred ones. Update management. I don't have permissions to do that because I'm in their sandbox, and the sandbox doesn't let me do this. Update management, this is what you did in your Windows Server classes with WSUS, Windows Server Update Services. This is essentially a web-based version of WSUS for your machines. Inventory, kind of the same thing. WSUS will inventory your machines. You can track them in here. Change tracking. Once I have the inventory, I can start changing those. Yeah. Same with config management. Policies, I think I can change. Yep. Or I can run a command in here. And let's see, we're actually getting kind of down to some of the more boring stuff, except for this guy. Help, I installed my virtual machine and now I don't remember what I set the admin user or password to. Not a problem. Come on down here to reset password, type in what you want the new admin password to be, or new username, new admin, what you want the new admin password to be. And then you click update and it goes into the virtual machine. It resets the admin username. It resets the admin password. At that point, once it's done, I can then RDP back into that virtual machine using the new username and password. I won't necessarily wait for that to finish. But there you go. You have your brand new environment with your virtual machine, your IPs, and so on, all configured together. For the most part, it's a virtual machine exactly like you're used to working a virtual machine. There's a few quirks as far as the disks and the network, but otherwise a virtual machine is a virtual machine. I can install whatever I want on here and then configure it however I want to. Conversely to our web servers, I at this point am fully in control of the operating system, which is good because I can make it look exactly like I want it to, but it's also bad because I am now responsible for that. That means I have to install the Windows updates. I have to make sure that the admin password's secure. I have to make sure everything is secure in exactly the way that it should be working in this environment.